At the end of this video, you will be able to connect the rechargeable battery to the charge controller, connect the solar panel to charge controller, find the charging time. Let us collect the tools, equipment and materials required to do this practical. Digital multimeter with props, trainees toolkit, crimping tool, solar charge controller type PWM, system voltage 12 to 24 volt, maximum output current 50 amps, battery 12 volt 10 ampere hour, connecting wires red and black as required. DC circuit breaker single pole 12 to 250 volts DC 6 amps. Lug terminals ring type 6 square millimeter, connecting the rechargeable battery to the charge controller. Safety precautions. It is very important to maintain the correct polarity while working with DC circuits like batteries and solar panels. Incorrect polarity can lead to short circuits or reverse current flow, which can damage the battery, charge controller or other connected devices. Take the rechargeable battery, which has to be charged, and observe the details printed on it. Identify the positive and negative terminals of the battery with the signs printed near the terminals. Set a digital multimeter to measure DC voltage. Place the multimeter red probe on the positive terminal of the battery and the black probe on the negative terminal of the battery. Note the measured battery voltage. Measure and cut 2 lengths of electrical wire required to connect the battery to the charge controller and the circuit breaker. Remove insulation sleeve at both ends for 12 mm and insert conductor into cable lug terminals as shown. Crimp the lugs using crimping tool on both ends of the cable and connect them to the battery terminals. Connect the DC circuit breaker in series with battery positive terminal as shown. Connect the other terminal of DC circuit breaker to the charge controller at the positive input terminal of battery. Connect the negative terminal of the battery to the negative battery terminal of the charge controller. Keep enough tightness using the screwdriver. Connecting the solar panel to charge controller. Identify the terminals on both the solar panel and the charge controller. The solar panel typically has 2 wires coming out of it, one positive and one negative. The charge controller also has terminals labeled for solar panel connection, often marked solar or PV, with positive and negative signs. Cut and strip the insulation from both ends of the wires attached to the solar panel and controller to expose the conductive wire. Connect the positive wire from the solar panel to the positive terminal on the charge controller. Likewise, connect the negative wire from the solar panel to the negative terminal on the charge controller. Ensure that the connections are secure and tight to prevent them from coming loose over time. Some charge controllers have screw terminals or other connectors to secure the wires in place. Finding the charging time. Once the solar panel and the rechargeable battery are connected to the charge controller, you will be notified when the battery starts charging through the controller display. Battery voltage will be displayed on the charge controller. Ensure that the display confirms the connection. Note down the battery voltage and time for every 5 minutes in the tabulation. Time at initial, the battery voltage is 12 volt. Time at 5 minutes, the battery voltage is 12.3. Time at 10 minutes, the battery voltage is 12.2. Let us discuss how to calculate the battery charging time. Divide the solar panel's maximum power output by the battery voltage to get the charging current. For example, if you have a 12 volt 100 watt solar panel and a 12 volt battery, the charging current would be approximately 100 watt divided by 12 volt is equal to 8.33 ampere. Divide the battery capacity by the charging current to estimate the charging time. For example, if you have a 100 ampere hour battery and a charging current of 8.33 ampere, the charging time would be approximately 100 ampere hour divided by 8.33 ampere is equal to 12 hours. This 12 hour is an approximate value. It may vary or depend on the sunlight that falls on the solar panel and the efficiency of the battery. Also, calculating the charging time of a battery connected to a solar panel involves several factors including the battery capacity, solar panel output, sunlight conditions, efficiency losses, and charging characteristics.
In this video, we have connected a rechargeable battery to the charge controller, connected solar panel to charge controller, found the charging time. This concludes this exercise. Thank you for watching. Hello everyone. In today's video, let us learn how to install a solar inverter.
At the end of this video, you will be able to install the solar inverter, connect the solar inverter to grid AC, commission the solar inverter. Let us collect the tools and equipment required to do this practical. Trainees toolkit, electric drilling machine 12 mm with hammering and drill bit, solar inverter with user manual, type MPPT, maximum power point tracking, input voltage 12 volt, output power 600 watt, output voltage 220 volt AC, DC circuit breaker 2 pole 12 to 250 volts, AC circuit breaker 2 pole 240 volts AC, digital multimeter with props, anchor fastener as required, measuring tape 3 meter length, HP pencil, connecting wires 2 square millimeter as required. Planning and installation of solar inverter. Choose your installation location carefully. Choose a location that is easily accessible for installation, maintenance, and potential repairs. Ensure there is enough space around the inverter for ventilation and airflow. Safety precautions. Avoid enclosed spaces or areas with poor ventilation as it can lead to overheating and reduced efficiency. Check the wall is capable of bearing the heavy load of the device and vibration free to avoid disruptive vibrations. Lift and move the solar inverter with the help of at least 2 people. Select correct size of dowels and screws that are suitable for the wall material and the heavy weight. Safety precautions. Do not mount the inverter on flammable construction materials. Always use a mounting plate supplied with the solar inverter. This inverter can make noises during operation which may be perceived as a nuisance in a living area. Measure the dimension of the solar inverter and mark the hole in wall. Gather the necessary tools and equipment for installation, including a drill, screws or bolts, wall anchors if needed, a sprit level and a screwdriver. Use a template to mark the mounting holes on the wall according to the mounting bracket or template provided with the inverter. Drill 4 holes in the marked location for screws as shown. Place the unit on the surface and align the mounting holes with the 4 screws holes as shown and mount the solar inverter firmly. Check if the solar inverter is firmly secured as shown. Connecting the solar inverter to the grid AC. Refer the user manual and note the rated voltage and current of the given solar inverter. Mount the DC and AC breaker near the solar inverter as shown. Remove the insulation sleeve at the end of the wires and prepare for the connections. Connect the positive and negative terminal of the DC breaker to the positive and negative terminal of solar inverter with same polarities as shown. Connect the AC output terminal of the solar inverter to the AC breaker. From the AC breaker, connect the AC output through the AC distribution box. Connect the on-grid solar inverter to the existing earth or ground. The ground terminal on the solar inverter is typically labeled GND or ground and is usually found on the inverter's chassis. It may be a screw terminal or a designated connection point. Safety precautions. This inverter is not allowed to operate in parallel. Please do not parallel connect more than one unit in AC output connector, otherwise it will damage this inverter. Commissioning of solar inverter. Turn on the DC breaker. Note, commissioning procedures for solar inverters can indeed vary between manufacturers and even between different models from the same manufacturer. Verify that all wiring connections, both DC from the solar panels and AC to the electrical panel, are correctly installed according to the manufacturer's instructions. Switch on the power button in the solar inverter. Select, after powering up the inverter for the first time, the language dialog as shown. Check the display or interface of the solar inverter for any error messages or warnings. Address any issues indicated before proceeding. Use the up-down buttons and to select language English. To confirm your selection, press the enter button. Use the buttons and to select the entry Yes. To confirm your selection, press the enter button. If you want to change your selection, choose No. The inverter starts a self-test which takes approximately 2 minutes. A countdown shows the remaining time on the display. The basic setup is finished. The standard menu is shown. Measure the output of the solar inverter to verify that it is producing the expected amount of power based on the available sunlight and the specifications of the solar panels.
In this video, we have planned and installed the solar inverter, connected the solar inverter to the grid AC, commissioned the solar inverter. This concludes this exercise. Thank you for watching. Hello everyone. In today's video, let us learn how to identify the resources and their need on the given fiber optic trainer kit.
At the end of this video, you will be able to identify different cables used in optical fiber communication, identify different connectors used in optical fiber communication, identify various sections in the optical fiber communication trainer kit. Let us collect the tools and equipment required to do this practical. Optical fiber trainer kit with instruction manual, assorted OFC cables with label numbers attached to each one, assorted OFC connectors with label numbers attached to each one. Identification of different types of cables used in optical fiber communication. Pick any one of the labeled optical fiber cable from the given assorted cables. Identify the name or type of cables used by referring to the data manual. Single mode fiber optic cable. They have a small core diameter, typically 9 micrometers, and are used for long distance communication due to low signal attenuation. Multi-mode fiber optic cable. They have a larger core diameter, typically 50 micrometers or 62.5 micrometers, and are suitable for shorter distance such as within buildings or campuses. Ribbon cable. Ribbon cables contain multiple fibers arranged in parallel ribbons. They are used in high-density applications where space is limited, such as in data centers or telecommunication facilities. Breakout cable. Breakout cables are designed for rugged environments or outdoor installations. They consist of multiple tight buffered fibers encased in a rugged outer jacket. Breakout cables are suitable for direct burial or installation in ducts. Identification of different types of connectors used in optical fiber communication. Pick any one of the labeled connector from the given assorted optical fiber communication connectors. Identify the name or type of connectors by referring the data manual used in optical fiber connectors. Record the name and its application. Standard connector SC. SC connectors uses a ceramic ferrule to deliver accurate alignment of the single mode fiber SMF. SC connectors are commonly used in telecommunications, data centers, and cable TV networks. Ferrule core connector FC. This connector uses a threaded container and a position locatable notch to achieve exact locating of the single mode fiber in relation to the receiver and the optical source. FC connectors are commonly used in laboratory and research environments as well as in some telecommunications and industrial applications. Straight tip ST connector. The ST connector's keyboard bayonet design is similar to that of a BNC, bayonet nut connector, or bayonet nail Conzelmann connector. ST connectors were once widely used in data communication and networking applications, but they are being gradually replaced by smaller connectors like LC and SC. SMA Sub-Miniature Version A connector. The obsolete SMA connector was the forerunner to the ST connector. SMA connectors are mainly designed for use with glass. They can also be used with plastic fiber optic communication. Lucent connector LC. The LC, sometimes referred to as the little connector, is a small form factor FOC that uses a 1.25 micrometers ferrule. LC connectors are widely used in data communication and telecommunications networks as well as in fiber optic transceivers and switches. Plastic fiber optic cable connectors. There are relatively fewer plastic connectors available when compared to glass fiber. These connectors are cheaper and are primarily designed for easy application. Enterprise Systems Connection Connector ESCON. These connectors were developed by IBM for interfacing peripheral storage devices, including tape drives, to their mainframes. Fiber Distributed Data Interface Connector FDDI. This provides data transmission at 100 Mbps in a dual ring token local area network within a 200 km range, primarily in high-speed LAN local area network environments. OptiJack connector. The OptiJack duplex connector resembles the universal RJ45 connector. OptiJack connectors are often used in structured cabling systems within buildings, campuses, or data centers. LX5 connector. The LX5 provides high density, high performance, and reliable connections. The LX5 connector is a specific type of fiber optic connector designed for military and aerospace applications as well as in harsh environments where ruggedness and reliability are paramount. Identification of various sections of the optical fiber communication trainer kit. Identify each section of OFC trainer kit by observing the kit and refer to the instruction manual. Frequency modulation. This circuitry would modulate the optical carrier signal with the analog modulating signal to create an FM modulated optical signal. Pulse width modulation. The transmitter would convert the modulated electrical signal into an optical signal suitable for transmission over optical fibers. Emitter circuits. In a fiber optic trainer kit, an emitter circuit typically refers to the circuitry responsible for driving the optical transmitter. Detector circuits. In a fiber optic trainer kit, detector circuits refer to the circuitry responsible for converting optical signals received by the optical receiver into electrical signals. Comparator circuit. These circuits compare the received optical signal strength or characteristics against a reference level and produce a binary output based on the result of the comparison. Phase-locked loop detector. A phase-locked loop is a control system that generates an output signal whose phase is related to the phase of an input signal. PLLs can be used for various purposes including clock recovery, phase modulation, demodulation, frequency synthesis, and carrier recovery. Function generator. A function generator can produce modulating signals for testing the modulation capabilities of optical transmitters. For example, it can generate sinusoidal, square, or triangular waveforms to modulate the optical signal's intensity or phase.
In this video, we have identified different types of cables used in optical fiber communication, identified different types of connectors used in optical fiber communication, identified various sections in the optical fiber communication trainer kit. This concludes this exercise. Thank you for watching.
Hello everyone. In today's video, let us learn how to display a word on a two-line LED.
At the end of this video, you will be able to construct a two-line LED circuit, test the two-line LED circuit. Let us collect the tools, equipment and materials required to do this practical. Trainees toolkit, digital multimeter with props, soldering iron kit, general purpose PCB, battery 9V with connector, diode IN5402, 2 numbers, decade counter IC CD4017, timer IC 555, positive regulator IC 7805, diode IN4148, 2 numbers, transistor SL100, 2 numbers, transistor TIP122 with heat sink, capacitor 10 microfarad 16 volt, capacitor 0.1 microfarad, capacitor 0.01 microfarad, preset 100 kilo ohm, resistor 10 kilo ohm 0.5 watt, resistor 470 ohm 0.5 watt 3 numbers, resistor 220 ohm 0.5 watt 5 numbers, LED 5 mm red 43 numbers, connecting wires as required. Construction of a two-line LED circuit to display a word. Collect all the components required and test them for good working condition. Identify the voltage regulator IC 7805, timer IC 555 and decade counter IC CD4017 by their part numbers printed on the top of the IC. Place the IC on the PCB, aligning the pins with the corresponding holes. Ensure that pin 1 is correctly aligned with its marking on the PCB. Start by soldering one pin first to secure the IC in place. Then solder the opposite corner pin to ensure proper alignment. In IC 7805 pin number, the unregulated input is connected to 1 and 2 and the regulated output is taken between 2 and 3. Connect the input and output pins of the ICs as per your circuit diagram. You can use wire jumpers and soldering on the PCB to make these connections. Connect the regulated output from IC 7805 to the input of timer IC 555 through the capacitors C2, resistor R1. 100 kilo ohm preset and capacitor C3 are shown in the circuit diagram. Connect the pins 8 and 4 of IC 555 to the positive supply and pin 1 to the ground or negative supply as shown in circuit diagram. Connect the output of the IC 555 pin 5 to pin 14 of the decade counter IC CD4017 as input. Connect pin 16 to the positive supply and pin 8 to the ground or negative supply of IC CD4017. Identify the SL100 transistor terminals, emitter, base, collector from its datasheet. The SL100 is a widely used NPN bipolar junction transistor BJT, primarily designed for general purpose amplification and switching applications. Take two numbers of SL100 transistors, namely T1, T2, and place them near the IC CD4017 decade counter. Make a mark on the terminals for easy identification. Connect the emitter terminal of both transistor T1, T2 to the ground. Connect the base terminals of transistors T1 and T2 to pins 2 Q1 and 4 Q2 of the decade counter IC CD4017 through the resistors R2 and R3, each 470 ohms as shown in the circuit diagram. Identify the transistor TIP122 from the part number printed on it and identify the terminals from its datasheet. Place the transistor TIP122 in the PCB, connect the collector terminal to the ground and negative supply. Connect the pins 1 Q5 and 5 Q6 to the base terminal of transistor TIP122 through diodes D5 and D6. IN4148 and the resistor R4 470 ohms are shown in the circuit diagram. Diode D5 and D6 must be connected with the correct polarity of the anode and cathode terminals. Take 43 numbers of 5 mm LED lights and divide all the LEDs into 5 different groups. Each group is used to display 5 letters, I, T and I in the first line and E and M in the second line. Align or design the 5 LED groups, each group by placing them in the alphabets I, T, I, E and M as shown. Connect all the LEDs in parallel with correct polarity. LEDs are polarized components, meaning they have a positive and a negative lead. The longer lead is typically the positive anode and the shorter lead or flat side of the LED's plastic body is usually the negative cathode. Once the LEDs are inserted into the PCB, gently bend the leads outward. This prevents the LEDs from falling out during soldering. To connect the LEDs in parallel, simply solder all the positive leads anodes of the LEDs together and solder all the negative leads cathodes together using wires. Connect the anode terminals of all LEDs to the positive terminal of the battery. Connect the negative terminals of all LEDs to the collector terminals of transistors T1, SL100, T2, SL100 and TIP122, T3 through resistors of 220 ohms and diodes IN5402 as shown in the circuit diagram. Testing the two-line LED circuit. Connect the 9-volt battery terminals to the input of the circuit. Connect the positive terminal of the 9-volt battery to pin 1 of the IC 7805 and the negative terminal of the battery to pin 2 of the IC 7805 as shown in the circuit diagram. Observe the output LED display cycle. Adjust the preset VR of stable multi-vibrator to change the clock frequency of decade counter to vary the display time. Observe the display output for the time or sequence of LED letters.
In this video, we have discussed how to construct a two-line LED circuit. Test the two-line LED circuit. This concludes the exercise. Thank you. Hello everyone. In today's video, let us learn how to demonstrate LCD display module and its decoder driver ICs.
At the end of this video, you will be able to identify the type of LCD display used in the digital panel meter, identify various decoder or driver IC in digital panel meter. Let us collect the tools, equipment and materials required to do this practical. Digital panel meter, trainees toolkit, digital multimeter with props. Let us discuss the LCD digital panel meters. LCD, liquid crystal display digital panel meters are devices used for measuring and displaying various electrical parameters such as voltage, current, resistance, frequency, temperature and more. A 7-segment display SSD or 7-segment indicator SSI is the most basic electronic display device that can display digits from 0 to 9. LCD meters typically offer high measurement accuracy, ensuring precise readings for various electrical parameters. LCD digital panel meters come with a specified measurement range for each parameter they can measure. LCD digital panel meters find applications in various industries and sectors, including industrial automation, process control, power distribution, energy management, automotive, aerospace, telecommunications, and laboratory instrumentation. Identification of the type of digits in LCD display. 3 half-digit LCD digital panel meter. A 3 half-digit panel meter is a type of digital meter that can display 3 full digits 0 to 9 along with one additional half-digit 0.5. The 3 full digits represent values from 0 to 999 while the half-digit extends the display range to 999 or 199.9 depending on the application. 4-digit LCD digital panel meter. A 4-digit LCD liquid crystal display digital panel meter is a type of electronic meter that utilizes LCD technology to display 4 full digits 0 to 9 simultaneously. The LCD display of a 4-digit panel meter typically consists of 4 segments capable of displaying numerical values from 0000 to 9999. 4 half-digit LCD digital panel meter. The display consists of 4 full digits representing values from 0000 to 9999 along with one additional half-digit that extends the display range to 19999 or 1999.5 depending on the application. The half-digit allows for increased resolution and precision in measurement readings. Identification of the type of LCD display. 7-segment LCD driver module. 7-segment LCDs are used to display numeric and alphanumeric characters, symbols and icons in 7-segment LED formats. Dot matrix LCD driver module. Dot matrix LCDs consist of an array of pixels arranged in rows and columns. Dot matrix LCD driver ICs control the activation of individual pixels, allowing for the display of text, graphics, and animations. Graphic LCD driver module. Graphic LCDs are capable of displaying custom graphics, images, and icons. These driver ICs are used in applications such as handheld devices, medical equipment, test and measurement instruments, and gaming devices. TFT – Thin Film Transistor LCD Driver Module. TFT LCD driver ICs are used to drive TFT LCD panels which offer high resolution, high brightness displays with fast response times. TFT LCD driver ICs control the activation of individual pixels using the thin film transistor technology, enabling vibrant color reproduction and smooth motion graphics. Identification of the decoder or driver IC in digital panel meter. Remove the back panel in the digital panel meter. Inspect the back of the panel meter to identify any screws, bolts, or other fasteners securing the back cover in place. Use the appropriate tools such as a screwdriver or nut driver to loosen and remove the screws or fasteners holding the back cover in place. Once all the screws or fasteners are removed, gently pry the back cover away from the main body of the panel meter. Look for any integrated circuits ICs that are connected to the LCD display or located near the display connector. Once you have located the IC that appears to be driving the LCD display, search for any identifying markings or labels on the IC itself by using a magnifying lens. These markings may include part numbers, manufacturer logos, or alphanumeric codes that can help identify the IC. Use the identifying markings found on the IC to search for its datasheet in online. Most manufacturers provide datasheets for their ICs which contain detailed information about the type IC specifications, pinout, features, and application notes.
In this video, we have discussed how to identify the type of LCD display used in the digital panel meter. Identify various decoder driver IC in the digital panel meter. This concludes this exercise. Thank you. Hello everyone. In today's video, let us learn how to dismantle the LED light, identify the connections of LED stacks, protection circuit and regulator.
At the end of this video, you will be able to dismantle the LED light and identify the connection of LED stack, identify the protection circuit components in the LED driver boards. Let us collect the tools, equipment and materials required to do this practical. Trainees toolkit, digital multimeter with props, magnifying lens with lamp, LED lamp 30 watt, soldering iron kit. Dismantling the LED light, identification of connections and the regulator section in LED light. Most LED lamps have a cover or enclosure. This could be a plastic cover. Look for clips around the edges and remove them using an appropriate screwdriver or knife. Sometimes the cover might snap into place, in which case you need to gently pry it open. Once the cover is removed, you will likely see the LED module. This is usually a circuit board with the LED mounted on it. These LED modules are connected with wires. Note down their positions and polarities or take a picture to ensure you can reconnect them correctly later. Heat the solder joints with the soldering iron until the solder melts. Gently pull the wires away from the joints and set the wires free. Once the LED module is removed, you can inspect it for any visible damage or issues. This might include burned out LED, damaged circuit, or other issues. Once all connections and fasteners are removed, carefully lift the driver board out of the lamp housing. Be mindful of any delicate components or wires that might still be attached. With the driver board removed, you can inspect it for any visible damage or issues. Look for burned components, signs of overheating, or other abnormalities. Identify the connection in the LED stack. LED stacks usually consist of multiple individual LEDs arranged in series or parallel configurations. Look for groups or rows of LEDs that are connected together physically, such as being mounted on the same substrate or board. Identify the protection circuit components in the LED driver boards. Identifying a fuse resistor of a fuse on a LED driver board. Fuse resistors typically look like standard resistors, similar to regular resistors, but they might be slightly larger in size. The primary purpose of the fuse resistor of a fuse is to limit the amount of current flowing through the LED driver circuit. In case of a sudden spike or surge in current, such as a short circuit or an overload, the fuse resistor or fuse will restrict the flow of current to a safe level. Identify the rectifier IC in the LED driver board. Rectifier ICs are typically small black rectangular or square chips with the multiple pins protruding from the sides. Rectifier ICs usually have markings on the top surface that indicate their part numbers. Most LED lamps are designed to operate on DC voltage, while the typical household electrical supply is AC voltage. The rectifier IC's primary function is to rectify the incoming AC voltage, converting into a smooth DC voltage suitable for powering the LEDs. Identify the driver IC in the LED driver board. LED driver ICs often have markings on the top surface that indicate their part numbers. LED driver ICs regulate the electrical current supplied to the LEDs. They ensure that the LEDs receive a consistent and stable current, which is essential for maintaining uniform brightness and color consistency across the LED array, especially in applications like LED lighting, where consistent illumination is important. Identify the switching transformer in the LED driver board. Switching transformers, also called as RF, radio frequency transformers, are typically located in the power supply section of the LED driver board. These transformers are used in variety of electronic circuit for several reasons, such as impedance matching to transfer maximum power, DC isolation between the circuits, voltage and current step up or step down, interfacing between unbalanced and balanced circuits, etc. Identify the capacitors in LED driver circuit. Capacitors are typically cylindrical or rectangular in shape with two leads. Capacitors are often used to filter out AC ripple or noise present in the input power supply. Capacitors can help regulate voltage levels by stabilizing the voltage across the LED driver circuit. Also, they can help suppress transient voltage spikes or surge that may occur in the power supply. Reassemble the LED lamp and test it. Ensure you have all the necessary components, including the LED module, driver board, housing, and any other parts that were removed during disassembly. Mount the driver board back into its original position within the lamp housing. Secure it in place using screws or other fasteners as necessary. Fix the LED module to its original position. Reconnect wires between the driver board and the LED module with correct polarity by soldering as per the marking made during the dismantling. Connect the LED to the power supply and check for its glow.
In this video, so far we have discussed how to dismantle the LED light and identify the connection of LED stack. Identify the protection circuit components in the LED driver boards. This concludes this exercise. Thank you. Hello everyone. In today's video, let us learn how to install a solar panel on roof.
At the end of this video, you will be able to select the suitable location on the roof to install the solar PV panel. Prepare the frame setup to mount the SPV panel. Select the correct position or angle and install the solar panel on a roof. Let us collect the tools, equipment and materials required to do this practical. Power drilling or hammering machine with suitable drill bits. Trainees toolkit. Solar panel 12 volt 50 watt 4 numbers. Safety helmet. Safety gloves. Base brackets 28 inches 6 numbers. Contact brackets 28 inches 6 numbers. Supporting brackets 14.8 inches. End clamp, mid clamp, M8 25 mm screws, bolt and nuts. Let us discuss the safety precautions to be taken before starting this practical. All instructions should be read and understood before attempting to install, wire, operate and/or maintain the PV module and the other electrical equipments. PV module interconnects pass direct current DC when exposed to sunlight or other light sources. Contact with electrical active parts of the module such as terminals can result in injury or death whether the module and the other electrical equipments are connected or disconnected. Wear suitable protection, non-slip gloves, clothes, etc. to prevent direct contact with 30 volt DC or greater and to protect your hands from sharp edges during the installation. Use electrical insulated tools to reduce the risk of electric shock. Cover the front of the modules in the PV array with an opaque material to halt production of electricity when installing or working with a module or wiring. Selection of location on the roof to install solar PV panel. Select the roof without shading for the solar panel installation. Avoid installing panels in areas where they will be shaded by trees, buildings, or other obstructions, as shading can significantly reduce energy production. Leave a safe working area between the edge of the roof and the external edge of the solar array for installation. Make sure the direction of installation of the solar panels takes sun into consideration. The tilt angle of your solar panels should match your latitude to capture the most sunlight throughout the year. In some cases, adjusting the tilt angle slightly to account for seasonal changes can improve overall performance. Pick an area of your roof to install the solar panels that gets the sunlight rays as long as possible each day. The solar panels can either be mounted flush on the roof or stand, or mounted at an angle to maximize the position of accessibility to the sun's direct rays. Flush mounting can provide a sleek and integrated look, blending the solar panels with the roof for a more streamlined appearance. Preparation of frame setup to mount the SPV panel. Evaluate the area where you plan to install the ground-mounted solar panels. Ensure that it receives adequate sunlight throughout the day. Prepare the concrete footings on the ground with a fastener bolt as shown. The number of concrete footings, size, and distance are determined by the solar panels' dimensions and wattage. Mount the base brackets with contact brackets with appropriate nuts and bolts as shown. Mount the supporting brackets between the base and contact brackets to form a triangle-shaped structure as shown. Attach mounting brackets or rails to the top of the mounting pillars. These brackets will provide the support structure for the solar panels. Use appropriate fasteners such as bolts or screws to secure the brackets firmly in place. Take two fixed tile rack and position them with rail as shown. Put one panel on the rack. Use two end clamps to hold and as shown. Install one end clamp on each end of the solar panel. These clamps are designed to securely hold the panel in place on the rack. Typically, they are placed near the edges of the panel. Mount the other solar panels with the existing ones at equal intervals and align them using end and mid clamps. Install the method for mid clamp and end clamp. Both end clamps and mid clamps are essential components of a solar panel mounting system, ensuring that the panels are securely attached to the mounting structure and can withstand various environmental conditions. Follow and use mid clamp fixed between panels. Selection of correct position of solar panel and installation. Select the best or perfect angle for solar panels with the help of manual to produce the maximum power. The angle of the solar panel determines how directly it faces the sunrise throughout the day. By adjusting the tilt angle to match the latitude of your location, you can maximize the amount of sunlight the panels receive, especially during peak sun hours. Refer to the perfect angle for standard roof pitch angle as shown. Mark the holes after selecting the place and angle of inclination. The angle of inclination for solar panel installation, also known as the tilt angle, is typically chosen based on the specific location of the solar installation and its intent purpose. Using a marker or pencil, mark the locations on the frame where the screw holes of the solar panel frame will align. Make sure the marks are accurate and evenly spaced. Drill the hole on the roof with the help of drilling machine as shown. Start by drilling pilot holes at the marked locations. Pilot holes help guide the larger drill bit and prevent the drill from slipping. Fix the frame with the help of screw. Place the panel on frame. Insert screws through the holes in the solar panel frame and into the pre-drilled holes in the mounting structure. Use a screwdriver or power drill with a screwdriver bit to drive the screws in firmly but not too tightly, as over-tightening can damage the panel or frame.
In this video, we have discussed how to select a suitable location on the roof to install the solar PV panel. Prepare the frame set up to mount the SPV panel. Select the correct position or angle and install the solar panel on a roof. This concludes this exercise. Thank you.
नमस्कार, मैं दिव्यांशी चौहान।
नमस्कार, मैं भगवती जबनाल। आप सभी का सीएससी कड़ी की तीसरी चर्चा में आपका स्वागत करते हैं।
हमने अभी तक बात की सीएससी सेवाओं के बारे में, जिसमें त्यागी सर ने हमें सीएससी का एक ओवरव्यू दिया। साथ ही हमने बात की पीएमजी दिशा योजना के बारे में।